Module 2.2, IDP Architecture Walkthrough. This is part of the AWS Security Fundamentals series from Uproot Security. In the last module, we looked at how IAM decisions are evaluated inside AWS. In this one, we zoom out to the identity layer that sits in front of all your applications, the identity provider, or IDP. Over the next 10 minutes, we'll walk through how an IDP brokers authentication, how it enforces MFA everywhere at once, and how it generates the audit evidence you'll hand to assessors. Let's get started. Here's our roadmap. 6 topics. First, the IDP as a broker, why your users should never authenticate directly to applications. Second, the directory as your source of truth, how groups, attributes, and memberships drive access control. Third, the single sign-on flow, step by step, every hop from the browser to a signed assertion. Fourth, MFA enforcement at the IDP layer, configure it once, enforce it everywhere. Fifth, SCIM provisioning, automating the joiner-mover-leaver lifecycle with time-stamped evidence. And sixth, the 5 standard evidence exports, the identity package that makes you audit-ready. Let's start with the broker model. Let's start with the core principle. Users never authenticate directly to applications. Picture the world without an IDP. Every user has to log in separately to AWS, to GitHub, to Salesforce, and to every other app you run. Each of those is its own attack surface, its own MFA configuration, and its own audit log. N applications means N places something can go wrong, and N places you have to collect evidence from. Now picture the world with an IDP. The user navigates to the app. The app doesn't ask for a password. Instead, it redirects the browser to the IDP with an authentication request. The user authenticates once at the IDP, and the IDP sends back a signed assertion. The app trusts that assertion because it's cryptographically signed by the IDP. There are 2 protocols you'll see doing this. SAML 2.0 uses an XML assertion and dominates enterprise applications. OIDC uses a JWT token and powers modern SaaS, and a PIS. In both cases, the IDP signs and the app verifies. These assertions are short-lived, typically 5 to 60 minutes. The payoff: auth logic lives in one system, you configure and audit one place, one policy covers every app, and user credentials never reach the application at all. If the IDP is the broker, the directory is its source of truth. The directory holds every user account and its status, group memberships, attributes like department, title, and employee ID, last login timestamps, and which apps each group is assigned. Access follows group membership, not individual grants. Look at the example. A group called Production AWS Admins contains Alice, Bob, and Carol, and that group is what grants access to the AWS console. You don't hand access to people one at a time, you manage the group. The operational impact is huge. Add someone to a group and access is granted instantly. Remove them and it's revoked. With 20 apps and 500 users, you're working from one control plane, and auditors get a single point-in-time snapshot, no spreadsheet reconciliation. The directory also drives dormant account detection. A last login older than 90 days flags a stale account. The status field tells you whether each account is active, suspended, or deprovisioned. And a point-in-time export answers your access review directly. Now let's walk the single sign-on flow step by step. Step 1, the user navigates to the app, say app.yourservice.com. The app finds no existing session. Step 2, the app redirects to the IDP, sending either a SAML authentication request or an OIDC auth request. Step 3, the user authenticates at the IDP. This is the only place a password ever travels. The app never sees it. Step 4, and this is the important one, the policy check. The IDP now asks a series of questions. Is MFA required? If so, challenge now with a TOTP code, a FIDO2 key, or a push notification. Is the device compliant? Check MDM enrollment, disk encryption, and OS version. Is the location allowed? Enforce the permitted IP or geographic range. Step 5. If the policy passes, the IDP issues a short-lived signed assertion, a SAML assertion, or an OIDC token. Step 6. That assertion is posted back to the app, and the app validates the signature against the IDP's public key. Step 7. The session is created, and the user is in. one login, one enforcement point, and a full audit trail of exactly what was checked and when. That policy gate in Step 4 is where your security controls actually live. That policy gate brings us to MFA enforcement. The key idea: configure MFA once at the IDP, and every single sign-on flow inherits that enforcement automatically. Without IDP layer enforcement, you're configuring MFA app by app, on AWS, on GitHub, on Salesforce, and so on. Miss one app and you've got a security gap. Worse, you have to pull MFA evidence from every system separately, and auditors end up with inconsistent reports. With IDP layer enforcement, one policy configuration covers every connected app. One export proves your MFA scope. There's no app-by-app evidence collection, and you can layer in conditional access based on device, location, and risk. Not all factors are equal. FIDO2 and WebAuthn are the strongest, suitable for FedRAMP and high-assurance environments. Passkeys are strong and phishing-resistant, meeting NIST AAL2. TOTP authenticator apps are acceptable for SOC 2 and ISO 27001 scopes. Push notifications are acceptable too, but watch out for MFA fatigue attacks, where an attacker spams approval prompts hoping you tap accept. And SMS or voice is deprecated. NIST Special Publication 863b no longer recommends it. The configuration target is simple: MFA required for all users, all apps, no exceptions by default. Authentication is only half the life cycle. The other half is provisioning and deprovisioning, and that's what SCIM automates. SCIM stands for the System for Cross-Domain Identity Management. Without it, the life cycle is manual. IT creates accounts in every app by hand. When an employee leaves, someone has to remember to disable 8 or more separate accounts. Miss one, and a former employee keeps access. That's both a security risk and a compliance finding waiting to happen. With SCIM, the lifecycle is automated. The IDP creates a user, and SCIM pushes that account out to all connected apps. When HR triggers offboarding, the IDP disables the account, and SCIM propagates that change to every app within minutes. And every one of those events is timestamped, which becomes your offboarding evidence. Picture the offboarding flow: HR system to the IDP, and from the IDP out to AWS IAM, GitHub, Slack, and Salesforce. Disable once, and it propagates everywhere with a timestamp logged at each step. As evidence, SCIM gives you a provisioning timestamp per app, a deprovisioning timestamp per app, account status at any point in time, and proof you met your offboarding SLA, say, under 24 hours. Apps with native SCIM support include AWS IAM Identity Center, GitHub Enterprise, Salesforce, Slack, and Google Workspace. For apps without it, you fall back to a manual checklist. Everything we've covered produces evidence, and it boils down to 5 standard exports. Number 1, the user list with status and last login, your full roster of active, suspended, and deprovisioned accounts, each with a last login timestamp. This answers your access review and dormant account detection. Number 2, connected applications, every app integrated through single sign-on. This proves the scope of your centralized identity control, exactly what's covered by your IDP policies. Number 3, the MFA enrollment report per user enrollment status and factor type with a target of 100% enrollment. This answers, can you demonstrate MFA is enrolled for every user? Number 4, the authentication policy configuration, the policy object itself, showing required factors, apps in scope, and conditional access rules. This proves MFA is actually configured, not just available. Export it as JSON or a PDF screenshot. And number 5, the audit log authentication events including successful logins, failed attempts, MFA challenges, and blocked access. This answers what actually happened during the audit period. Forward it to your SIEM or export it as CSV. Let's bring it together. 6 takeaways. 1. The IDP is the broker. Users authenticate to the IDP only, and apps receive signed assertions. 2. The directory is your source of truth. Group-based access means one place to manage and one place to audit. 3. Single sign-on has a policy gate. Every login runs through a check for MFA, device, and location. 4. MFA belongs at the IDP. Configure it once, it inherits to all apps, and one export proves it. 5. SCIM automates the lifecycle. Offboarding happens in seconds, and the timestamps are your evidence. And 6, those 5 exports make you audit-ready: user list, connected apps, MFA enrollment, policy configuration, and audit log. Up next, in Module 2.3, we'll get into least privilege access and a WSIM design. See you there.